Welcome to Brain Vision.
Okay, in this question, two stereo speakers are there, okay, like this, and the distance between two stereo speaker is 2.4 meter. Okay, a person stand at a distance of 3.2 meter directly in front of one speaker. So let's suppose this is the ear of the person, and that is 3.20 meter distance from the first speaker. Okay, so we have to find out the frequency in the audible range, that is from 20 to 2000 hertz, okay, for which the listener will hear a minimum sound intensity, and the velocity of the sound, okay, that is given 320 meter per second. Okay, so no problem. First of all, let's suppose this is source 1, this is source 2. Okay, so we can find out a diagram. This is S1, S2, and that is L. So this will be a right angle triangle. Okay, and the path difference from here, it will be this distance S2L minus this distance S1L. So S2L minus S1L. Okay, so S1 S2, that is 2.4, and S1L, that is given 3.2, and S2L from here, it will be the square root of this square and this square. Okay, so it will be square root of 2.4 square plus 3.2 square minus S1L, that is 3.2. So when we solve 2.4 square plus 3.2 square, it will be 16 minus 3.20. So square root of 16, that is 4, and minus 3.20, it will be 0.80 meter. Okay, so this is the path difference delta x. Okay, and we have to find out the frequency. So we know the formula of path difference, that is delta x, that is, okay, if we can say we have to find out the frequency in the audible range, so there should be a destructive interference. Okay, for that path difference, it will be 2n plus 1 divided 2n plus 1 multiplied by lambda by 2. Okay, and the wavelength, that is velocity by frequency. So velocity is 320 divided by frequency f. Okay, so we can put the values here. So first of all, delta x, that is 0.8 meter, we have find out. So 0.8 is equals to 2n plus 1, okay, multiplied by lambda by 2. Lambda is here 320 by f, so 320 by 2 and f. Okay, so from f, it will be 2n plus 1 multiplied by 320 divided by 2 and 0.8. So when we solve, it will be 2n plus 1, okay, multiplied by 200 hertz. So this will be the formula for the frequency, and now we can put n equals to 1 2 3 4, okay, to find out the frequencies that can hear in the audible range from 20 hertz to 2000 hertz. Okay, now put n equals to 1 2 3, okay, and when we reach 49, okay, the last point 49, that is when we solve, it will be 49 multiplied by 200. Okay, so the last audible to the 9800. Okay, but we have to find out the frequency from 20 hertz to 2000 hertz. So we will put the values of n to the integer from starting from n equals to 1. Thank you.